In this video, we're going to look at some more trig integrals. Here we have integral cosine squared x times sine squared x dx. So we have even power of cosine x and even power of sine x. We're going to apply the half-angle trig identities. So we have integral 1/2 1 plus cosine 2x times 1/2 1 minus cosine 2x dx. Let's label these. So this part of the integrand, this part is cosine squared x, and this part of the integrand is sine squared x. Alright, now 1/2 times 1/2 is 1/4. We can pull that out of the integral. We get 1/4 integral, and we can just fold this out. We get 1 minus cosine 2x plus cosine 2x minus cosine squared of 2x integrated with respect to x. We can simplify this. Cosine 2x cancels with minus cosine 2x. We get 1/4 integral 1 minus cosine squared of 2x. And we can just apply a trig identity. That's 1/4 integral sine squared of 2x. Now, so the trig identity that we applied here was cos squared x plus sine squared x is equal to 1. So you can imagine we have cosine squared of 2x plus sine squared of 2x is equal to 1. Same thing. Alright, now we have to apply another trig identity, namely a trig identity for this one, sine squared 2x. So when we already have that, that's 1/2 1 minus cosine 2x. But we have to adjust that a little bit. So sine squared 2x is going to be 1/2 1 minus cosine of 4x. Notice the 2-to-1 relationship. We have 2x here and we have 4x here. Alright, so let's write this down. We get 1/4 integral 1/2 1 minus cosine 4x dx. Now 1/4 times 1/2 is 1/8. We can just pull that out of the integral. We get 1/8 integral 1 minus cosine 4x dx. Alright, so what we have is 1/8 integral 1 minus cosine 4x dx. That's 1/8. Let's integrate this. Integral of 1 is just going to be x. And integral of cosine 4x is going to be sine 4x divided by 4. We're reversing the chain rule. We're applying the substitution technique. Plus c. So integral of cosine squared x times sine squared x dx is what we have above. That's 1/8 times x minus sine 4x divided by 4, close bracket, plus c. Alright, let's look at another question. Here we have integral third root of sine x times cosine cubed x dx. Whenever you see a kind of a complicated expression involving trig functions and you find an odd power of cosine x or sine x, it's a good bet that the best strategy is to reduce the odd power by 1. So let's do that. We have integral third root of sine x, and let's reduce cosine cubed x, that's cosine squared x, times cosine x dx. The next step is to apply a trig identity and to rewrite cosine squared x as 1 minus sine squared x. Why do we do that? Well, the reason is we can then apply the substitution technique with u is equal to sine x. Alright, let's do that. So we have integral third root of sine x times cosine squared x, that's 1 minus sine squared x times cosine x dx. Now let's apply the substitution technique. We will let u be equal to sine x. Its derivative du will be equal to cosine x dx. Alright, let's label these. So third root of sine x, that's third root of u. 1 minus sine squared x, this is 1 minus u squared. Cosine x dx, that is du. So the whole integral has been transformed by the substitution technique to something that involves u, and it will be easy to solve. So we have integral u to the 1/3 times 1 minus u squared du. Alright, so what we have is integral u to the 1/3 times 1 minus u squared du. Let's multiply u to the 1/3 through, and we get integral u to the 1/3 minus u to the 1/3 times u squared. We add up the exponents, we get 1/3 plus 2. So we have integral u to the 1/3 minus u to the 1/3 plus 2, that's 6 over 3 plus 1 over 3, that's 7 over 3. U to the 7 over 3 du. Now let's integrate term by term. Integral of u to the 1/3 is going to be u to the 4/3. Divide by 4/3, we're reversing the power rule. That means multiply by 3 over 4. And similarly, integrate u to the 7/3, that's going to be u to the 7 over 3 plus 3 over 3, that's 10 over 3. And divide by 10 over 3, that's the same as multiply by 3 over 10 plus c. But now let's put u back in. U is equal to sine x. So what we get is 3 over 4 times sine x to the power of 4/3 minus 3 over 10 times sine x to the power of 10/3 plus c. So the integral of 3rd root of sine x times cosine cubed x dx is what we have above. Alright, let's look at one last question. Here we have integral cos x plus sine x divided by sine 2x. So we're going to apply this trig identity. Sine 2x is 2 sine x cos x to make things easier to do. So we have integral cos x plus sine x divided by sine 2x. We'll apply the trig identity. That's 2 sine x cos x dx. Now we're going to split up the fraction. So we have integral cos x divided by 2 sine x cos x plus sine x divided by 2 sine x cos x. The reason for splitting up the fraction was so that we can get these cancellations. Cosine x at top cancels with cos x in the denominator, and similarly sine x at top cancels with sine x at the bottom. So what we have is integral 1/2 times 1 over sine x plus 1/2 times 1 over cos x dx. So let's pull out the 1/2, factor out the 1/2, I should say, 1/2 integral, and 1 over sine x, that's just cosecant x. And 1 over cosine x, that is secant x, integrated with respect to x. Alright, so we have 1/2 integral cosecant x plus secant x. Let's now split up the integrals. So we have 1/2 integral cosecant x dx plus 1/2 integral secant x dx. Now, what is the integral of cosecant x? It turns out that we have to memorize that. So that's going to be ln of cosecant x minus cotangent x. Similarly, we have to memorize the integral of secant x. That's going to be ln of sec x plus tan x plus c. So the integral of cos x plus sine x divided by sine 2x integrated with respect to x is what we have above. So we applied lots of trig identities here. So these are some of the things you have to memorize. For example, cosine squared x is 1/2 1 times 1 plus cosine 2x. So similarly, cosine squared of 2x would be 1/2 1 plus cosine 4x, because there's a 2-to-1 relationship. When this is x, here we have 2x, so when we have 2x here, we will have 4x here. And cosine squared x plus sine squared x equals 1. We also apply this one. Sine squared x is equal to 1/2 times 1 minus cosine 2x. We apply this one as well. We also apply the double trig identity. Sine 2x is 2 sine x cos x. And we have to memorize integral of secant x dx and integral of cosecant x dx. And those are some of the things you should memorize so that it's easier to solve these integrals. All right, thanks.